Okay, these are your notes for section 6.5, completing the square. Here's a journal choice for you. This section is going to go back and forth from standard form of an equation to vertex form of equation. This is very, very important. Standard form is really nice because it is calculator friendly. You can go right into that calculator. But vertex form is nice because it's very easy to graph by hand, and you can tell a lot just by looking at that equation. So today is a way to go back and forth between the two. This is very old school Algebra 2 material. I'm sure anybody you've ever known that has taken Algebra 2 can remember doing this. Your parents probably could even have some insight on this one today. Okay? I think you'll enjoy it. Here's our view. It's very easy to go from vertex form to standard form because all you have to do is expand. Okay? So we're going to take y minus 4 equals, and this will be x squared minus 12x plus 36. I did the shortcut that we've been talking about, but you could go ahead and multiply x minus 6, and double distribute if that makes you feel better. Okay? Add 4 to both sides, and standard form is, I'll write it over here, y equals x squared minus 12x plus 40. That's very easy to do. Okay, it's a little more difficult to go from standard form to vertex form. These are the steps. You're going to want to write them down in your notes. Okay, the first thing we're going to do is you're going to move the constant, that c value, to the side with the y. Okay, so then we have y minus c equals x squared plus bx. After that, we're going to figure out what we can do so that we have something that looks like x minus 2 squared. Okay, that's a factor that's called a PST, a perfect square trinomial. X squared minus 4x plus 4. Perfect square trinomials have a couple characteristics. The first term is a square, the second term is a perfect square, and the middle term is half, it's negative 2ab. It's half of the product of this and this. Okay? Oops, sorry. So basically what we do is we're going to figure out what we need to add here, the C term, kind of, is a C term, to make this work out. Okay, and this is the key. It's going to be half of whatever B is and then squared it. Okay, so we'll add that to the side. But when you add something to the right side, you have to also add it to the left. Then you'll go ahead and factor that right side because it will now be a perfect square trinomial, so you can easily factor it. And then it's finished. Then it will look like it's supposed to look. This is going to make so much more sense when we do an example, so let's go ahead and jump right into an example here. 8x. We're going to just work on the perfect square trinomial thing. We're going to figure out what do I need to add, how can I factor it. Okay, what I need to add here, I'm going to take half of 8. Half of 8 is 4. 4 squared is 16. 16 is what I need to add. I can now factor this. This is x plus 4 quantity squared. Okay? This one is a little trickier because it's dealing with a b. Half of b is b over 2. B over 2 squared is b squared, oh, it's too big, over 4. I might need to make it like right in between there, I don't know. I guess 2 is all I got. Alright, so this will be x, there, that's nicer. It's when what comes up in this second part of the binomial squared is what this was when you cut it in half. Okay, so when you cut this in half, this is 4. 4 shows up again right here. When I cut this in half, it was negative b over 2. Negative b over 2 shows up right there again. Okay? Okay, half of b over 4. B over 4. Half of b over 4 is the same thing as dividing it by 2 or multiplying by 1/2. That's b over 8. Squared, that's b squared over 64. Because you square the top and square the bottom. And that's going to be x plus, it's a plus this time because that's a plus sign, b over 8 quantity squared. Okay? We got some abstract ones. Most of them are just going to be numbers, especially when we're dealing with these equations, but it's nice to see the patterns here. Okay, let's do the whole thing. That was just like a little warm-up. Now we're actually going to do the whole thing. Step 1 said to move c, so I'm going to subtract 40 from both sides. Minus 40, minus 40. I now have y minus 40 equals x squared plus 12x. Complete the square. Now I need to make this a perfect square trinomial. Half of 12 is 6. 6 squared is 36. I just added 36 to this right side. That's not legal. Now it is legal because I did it to both sides. It has to stay equal, guys. If you just add 36 to this right side, your equation is no longer equal. You have to add it to both sides. I now have y minus 4 equals, go ahead and factor this out, x plus 6 quantity squared. So you see, and you could write it with y all the way by itself if you want. The vertex is going to be at the left 6 at 4, negative 6, 4. I could see it very easily. I couldn't see that before unless I graphed it in my graphing calculator. Okay? So you're going to move the c, take half of b and square it, factor, finish it up here. Okay? Let's try it again. Minus 7, minus 7. Y minus 7 equals x squared plus 3x. Half of 3 is 1.5. 1.5 squared is, I think, 2 1/4. Yeah. What you do to the right, you have to do to the left, or vice versa. So negative 7 plus 2.25 is negative 4.75. What was this when I cut it in half? 1.5 quantity squared. You can get all the way y by itself. The bell's going to get ready to ring here, guys. Okay, that vertex at negative 1.5, 4.75. Alright, that procedure you'll get used to the more of these problems that you do. What happens if there's a number in front of the x squared? Everything will be the same except, and kids are going to miss this, you guys are going to mess this up, so really be careful. You have to factor out that coefficient. To complete the square, you can't have anything in front of the x squared, so you need to factor it out first, just like you used to with a GCF. And this is going to affect what you add to both sides, because you're going to actually have to multiply by that thing you factored out, okay? Let's see these examples. 6x squared minus 18x minus 5. Move the constant just like before. Plus 5, plus 5. So I have y plus 5 equals 6x squared minus 18x. That 6 is not okay there. I have to factor it out. So now I have y plus 5 equals 6 times x squared minus 3x. 6x squared minus 18x. Just factored out that GCF. Here we go. Half of 3, 1.5. 1.5 squared is plus 2 1/4. I added that to the side, but that's not really what I added. I didn't add 6 times 2.25 is what I added 6 times. I'm stuttering all over my words. I'm not adding 2 1/4. I'm adding 6 times 2 1/4. So that's what I need to add to the left side. And 6 times 2 1/4 is 13.5. So that is really what I added to this side here. So I have y plus 18.5 equals 6. Go ahead and factor it. X minus 1.5 squared, because this number is whatever it was when I halved it. I could get all the way y by itself. Alright, so this vertex is to the right 1.5, down 18.5. Okay, it's going to be a narrow parabola because of that coefficient of 6. Okay, I feel like I stuttered all over my words on that example. So let's take a look at this one, next one together, and I'll see if I can speak more clearly. Okay, y equals 1/2 x squared minus 3x plus 8. Okay, step 1, subtract 8 both sides. Y minus 8 equals 1/2 x squared minus 3x. Now, it's not okay to have that 1/2 there, so I'm going to factor that guy out. 1 minus 8 is 1/2 times x squared minus. What is 3 divided by 1/2? It's going to be 6x. 1/2 times 6x is 3x, because you have to distribute it back in there. Let me move this over here. Half of 6 is 3. 3 squared is 9. But am I really adding 9 here? No, I'm adding half of 9, which is 4.5. That's what I really added to that side. So -8 plus 4.5. Y minus 3.5 equals 1/2 times x, what was it when I halved it? Minus 3 quantity squared. You can get y all the way by itself if you want. This math stuff is optional, guys. And then you can see what you're doing. Okay, I will almost guarantee you're going to have a couple of questions when you do the first few on the worksheet. Usually kids mess up a few times, but then you'll get going and then you'll know what you're doing. Okay, this is a review because I think it shows up a couple times on your homework. Explicit formula for an arithmetic sequence. You remember this? A sub n, the mystery term, is the first term times n minus 1 times d. That's that constant difference. That's that number you add or subtract over and over again. Make sure that you do distribute that into the n minus 1, okay? So if it makes more sense to write like this, that's fine. Just make sure you don't lose the sign that goes with your d, and make sure you distribute that guy through there. Okay, only in vertexes, because you can't have more than one vertex. It's vertices, not vertexes. Okay, I will see you later. Bye.